Hello everyone, good afternoon. Welcome to our webinar today to discuss a very interesting topic on evolving trends in grid scale energy storage in India. The session is organized by JMK Research, a specialist consulting firm focusing on renewables and e-mobility segments. The session is organized and supported by Institute of Energy Economics and Financial Analysis, IEEFA, a leading think tank that examines issues related to energy markets, trends, and policies globally. So the webinar will consist of a small presentation on the ESS market, which will be presented by my co-panelist here, Mr. Charith from IEEFA. After the presentation, there will be an interactive panel discussion with our eminent speakers. At the end, we'll have a 15 minutes Q&A session also. So participants are welcome to submit their questions in the Q&A box at the bottom of webinar window. And to take the discussion forward, I would like to invite our very diverse mix of industry experts, which is with us here today. A quick intro of our experts. First, we have Mr. Debmalya Sen, who is India lead at Advanced Energy Solutions at World Economic Forum. Next, we have Mr. Lakshmi Narayanan, who is GM Business Development at Ayana Renewables. Next, we have Mr. Debabrat, who is Manager Design Engineering of Renewable Energy at NTPC. And we have also with us Mr. Charith Konda, who is Energy Specialist at IEEFA. For setting up the context of this discussion, we have prepared a brief presentation, which Mr. Charith will be presenting to in front of all of us today. So Charith, you can take it forward from here for the presentation.
Yeah, sure. Thanks, Prabhakar. And thanks for having me here. Welcome all. I'm going to share a brief presentation of the research that we have done and the findings we have arrived at. Allow me, please, to share my screen. I hope you all can see my screen.
Yes, it is visible.
Yeah, thank you. So yeah, I think Prabhakar has already introduced about IEEFA and JMK, so I'm not going to spend time there. So straight away dive into the our findings. So we did a study on the evolving trends in grid scale energy storage market in India. As you all know, this is a hot market, and a lot of public discourse is happening in this. So we try to capture what's happening and what's not happening. I'll walk you through a few slides. So just to get a sense of where we are in India's energy storage market. So predominantly it is dominated by pumped hydro storage and battery energy storage at the moment. So we have an installed capacity of around 33 plus megawatt in the battery energy storage systems and around 4.7 gigawatt of pumped hydro systems. Again, there is around 2.7 gigawatt of pumped hydro capacity in the development stage as we are talking. So, and when it comes to targets, if you go by the CEA's, the Central Electricity Authority's numbers, we have a target of reaching about 60 gigawatt of energy storage combined for all technologies by 2030. If you see, majority of the share is to be contributed by the battery energy storage systems, expecting a decrease in the value of batteries as well as the modular structure of these projects. And so far in India, until November 2023, around 8 gigawatt of energy storage tenders were awarded, and some of these tenders are at various stages of getting completion, the projects under these tenders. And India is also aiming, as you all might be aware, of building a battery energy or battery manufacturing capacity in India to reduce reliance upon global supplies. So we are supporting it through various measures. We'll talk about it in a minute. But India's capacity in the pipeline is around 96 gigawatt hour. So why do we need all this energy storage is essentially, as you all might know, is to smooth out the variability in renewable energy sources. So for India to transition and achieve the climate goals, energy storage plays a very important part in firming up the uh, uh, renewable energy supply. And yeah. Uh, So what's happening from the government perspective? How is the government supporting this new industry? Is they've been announcing several energy storage policies starting from July 2022, where India has announced energy storage obligations similar to renewable purchase obligations that we have. And since then, a number of ESS or the energy storage technology specific policies are being announced. For example, in April 2023, government has announced the pumped hydro policy, and then there is a firm and dispatchable renewable energy guidelines were issued in 2023, and the national energy storage policy later in 23. And as I said, to develop the manufacturing capacity, some kind of a production linked incentives were also being given for battery manufacturing. Beyond that, for battery energy storage systems, as the costs are currently higher, the government has announced recently in September 2023 a viability gap funding, which aims to reduce the levelized cost of storage to somewhere around 6 rupees per unit, which is currently around 10 to 11 rupees per unit. So that's the policy scape on policy landscape on energy storage. So what's happening since the storage policies are announced is India's tender capacity has grown up a lot since 2021. So if you see, until 2021 is just 1,794 megawatt of grid scale ESS energy storage capacity was awarded, whereas in just 2023, in 1 year alone, close to 35 gigawatt of storage capacity has been tendered. And of course, given the cost considerations and the technology maturity, the pumped hydro storage has accounted for most of the tendered capacity, more than half, around 56% of this tendered capacity. And majority of this, if you see geographically, where they are coming is most of the storage plants will be connected to the interstate transmission system, and as such, they can be located anywhere in India. That is what we call it as pan-India projects. Um, Moving forward, so how are these tenders have been kind of developing, or evolution of these tenders have been happening over a period of time? I don't think so. We are completely the maturity of the industry has achieved, but the government is trying various ways of achieving a more efficient tendering system. And this might vary again, where do you want to keep your storage system as an asset, as a generation asset, or as a transmission and distribution asset for providing various grid services, or behind the meter, or so it depends on what kind of application the asset would be used. So tenders have been evolving over a period of time. So the first one was simply kind of increasing the availability factor and availability of solar power by pairing it up with solar and wind, and plus the battery energy storage system. So basically, these were used for smaller project sizes. It started in March 2018 with SECI awarding 100 megawatt of tenders. So these could be even used for off-grid applications just to replace the diesel gensets. And then later, India move to peak power supply contracts, because as you all know, India has been hitting record peak power consumption every year just before summer hits in. So that's where the concern is, how do we address those? So tenders have been designed to meet these peak powers with a combination of storage with renewable energy. So post then a newer concept came, something like round the clock tenders, which ensure round the clock availability of power to the off-taker rather than only a few hours when the sun is out or the wind is blowing. So this RTC tenders, although it's called round the clock, it's not entirely 24 hours power supply, but there is like a clause of 60 to 70% or 80% of availability factor should be there from these projects. So this RTC is kind of evolving into the last one, which we're talking about, is a firm and dispatchable renewable energy tenders. So FDRE is what we can call perhaps as the RTC 2.0, which is an evolution of the RTC tenders, which have higher um, um, availability factor requirements. And the standalone energy storage systems is also, again, so that's what application oriented wise, this is a tender that will be fine tuned to for storage assets, which will be primarily supporting the transmission and distribution assets for providing various grid services, ancillary services. So this standalone ESS is also a tender type that is gaining prominence over a period of time. So if you see auction results, some of these auctions that has been recently held of grid scale ESS tenders, you see the megawatt tendered in the bar, and the dots are the per unit prices that have been discovered. So a number of factors could have impacted these discovered tariffs, but you can see the variations over a period of time. They've been coming down mostly on an average, but again vary within that type of the discover tariff within the type of tender. So if you see the discover tariff in RTC tenders is somewhat appearing lower than the peak power supply tenders. So what we assume here is that, or we found that the because of the higher utilization rate of the storage asset in RTC tenders, that's the reason, one of the reasons where the price is coming down. Also, standalone ESS prices have multiple use applications, and they can value stack their storage capacities and have multiple ways of earning revenue. So in for providing grid services, so we see these tariffs are also would be falling as we go forward. Um, and also some of the other factors that could be influencing these discovered prices are the end use applications, availability factor requirements, the duration of the PPA itself. We have seen in some of these tenders where the duration of the PPA is higher, the tariffs are lower, and the type of technology, whether it is a pumped hydro or whether it is battery, within the battery, what kind of type of batteries. So this will be evolving, and we'll be closely watching this space. And yeah, who are the players? There are a number of players when if you want to divide the in storage market. So there are developers, and again within developers there are EPC players, there are biotechnology providers, service providers, as well as battery manufacturers. So there are a number of companies that have been doing these projects or plan to do projects, and then there are OEM suppliers, LG Chem, the primary battery supplier, and Samsung, and then of course there are tendering authorities, various tendering authorities, central government as well as state government entities. So far, the capacity awarded, if you can see, it's from by the maximum was garnered by Greenco, followed by Renew and Acme and other companies moving forward. And we have a panelist from Ayana as well, so they'll be able to know more about this from the panelist. Um, so coming to the last few slides, what not all is good. Of course, there are some challenges. and risks for the energy storage markets. If you see, the first one being, if you see in the last 2 years, the battery prices were expected to go down, but since then they have went up in 2022 second half and 2023, probably because of the supply chain shocks that the world economy received since COVID lockdowns. And however, the expectations are the battery prices should fall continuously going forward with technology development, the economies of scale kicking in. However, when you are doing competitive bidding, the developers have to be extremely cautious of these fluctuations in the battery prices. And even though India is developing, or it's in a very nascent stage of for developing manufacturing capacity for batteries, still we are reliant on imports for minerals as well as the battery packing facilities. So this is something that the government has to keep in mind, given the global supply chain shocks. And further, as we are talking about energy storage as an asset at the transmission and distribution level, the infrastructure has to be upgraded so that the projects can be located at place anywhere in India, and the power could be evacuated, or power could be supplied to the storage asset and could be evacuated, and real time can be traded on the power market. So these are all very important for making ESS a commercially viable solution. Yeah, one of the reasons why we see battery storage to overtake pumped hydro storage is the long gestation period of the PHS projects. They are expected to take anywhere between 6 to 10 years, involving a lot of permits and environmental clearances, mm, and compensation measures. So speeding up these PHS project development would help in overall energy storage growth. Yeah, again, BESS capacity so far, installed capacity is less than 50 megawatt. So as India has to reach some 60 gigawatt of storage capacity. So a lot of ecosystem has to be developed, including suppliers and associated supply chain has to develop. So this all has to be consciously focused to be developed. The way forward, what we see is that the firm and dispatchable renewable energy tender designs will dominate because they closely replicate the thermal power supply, high availability factors, and it has a demand following feature. So on demand, you can supply clean power through these FDRE projects. So we see it's a win-win situation for both the off-takers as well as the developers. So we see FDRE really dominating the tenders going forward. And most also new grid scale ESS tenders are allowed to be sell power on other revenues. So we see that power markets opening up of ancillary markets, and having a real-time primary reserves market would also help ESS, the energy storage projects, to pick up. In the near term, we see large grid scale ESS energy storage projects to favor pumped hydro, given the technology maturity as well as the lower per unit prices or the levelized cost. However, a decline in battery prices as the technology matures in the batteries, the modular structure of the battery projects would push them to dominate the pumped hydro storage. And in the long term, green hydrogen based energy storage may also play a role. With that, I conclude the presentation, and I give over to Prabhakar for the panel discussion.
Thank you, Charith. It was a very well structured presentation. So after setting the context, we can initiate the discussion. So I will begin with you, Debmalya. So you have followed the ESS market closely for past several years, and having seen through its ups and downs. So building upon the presentation and what the content was given, can you give an outlook of where the market has been going and what are the developments, a basic outlook and trends that you are seeing?
Thank you. I think a lot has been covered in the presentation. But yeah, let me give you some numbers. Let me start off with some numbers. As on date, India has issued 50 tenders where storage was included. Okay. Out of those 50, 25 tenders just came in 2023 alone. If I take just from July till today, we are still 9 days away. No one knows if one more tender comes out. So we have 17 tenders which came from July to December. Okay, and of course, a majority of them were FDRE. Ever since the guideline came up on RD plus ESS, the device guideline came up, I think there were six FDRE tenders associated with a renewable capacity of 11 gigawatts. Of course, you don't know what is the storage which will come in these FDRE tenders. Of course, the storage in these tenders will not be huge. It will be minimal. So you can't rely on FDRE to get the storage numbers. They won't be very handsome. They will be limited. Now, also what we saw this year, we closed 8 tenders. 6 that were issued this year alone and 2 from the previous year. It would have been 9, but 1 got cancelled in the way. So we have 8 tenders which has been closed this year. And the price discoveries, we have seen that if it is RD plus storage, the price discovery has been in the 4 to 4.5 range. Okay. Now the good news. The good news is that battery prices had started to decline. If you see what BNEF and even what Goldman Sachs report says, there has been around a 14% decrease from 2022 to 2023. But that is not a thing on which enthusiasm builds. Enthusiasm builds on the fact that metal prices have started to stabilize. So what happens is whatever happens in the metal industry comes to the battery prices the next year. So if metal prices are stabilizing and this is showing inclinations to go down, it means that your storage costs will go down. Okay, if that goes down, the LCOE or the LCOS, whatever you prefer to calling it as, will reduce. Now, pumped hydro, of course, as on today, anything beyond, and the myth also was broken that anything till 4 hours, it's only batteries. 4 hours and beyond, it is pumped. No, we have seen tenders with even 2 hours of storage where pumped hydro has been a winner. And we have also seen tenders with 8 hours of storage where batteries have been a winner. This is news from Australia last week, where batteries actually won a tender which required 8 hours of continuous discharge. So it's both ways. So those myths are broken now. The batteries are only for reverse duration, pumped hydro is only for higher duration. Now, the reason why there is a crunch now is because new pumped hydro plants, which are today in construction, will take around 5 hours to come into play. But these FDRE tenders, whatever tenders, we have 19 tenders which are live. Okay, out of those 19, if I keep aside the standalone ones, we have around 12 tenders which are RD plus ESS. Okay, now if in these storage has to come in, then it has to be invariably battery. It cannot be pumped because it don't have a plant which you can get into these things, and which are there has already been contracted, almost major portion of that. So therefore, that is where we see. But what is the crux here is that FDRE will roll, but FDRE will not give you your storage numbers. Okay, because the thing is, you do not have a minimum storage capacity that is mandated in this. Now, we had this in the framework for energy storage, where it was said that every tender should have 5% at least for storage associated with that. But if that is not there, then gaming can start, of course. But the good part of the story is we will have standalone storage projects, maybe pumped hydro, maybe batteries, they will be there. Last month itself, GUVNL came out with a 250 megawatt, 500 megawatt hour standalone BESS project. As we talk, Rajasthan has gone for an approval to come out with 1,000 megawatt into 6 hours of pumped hydro, of course. And there is also a discussion that more varieties will come. So we are in process of seeing something on CSP with renewables for addressing RTC coming up next year. So what I'm saying is you will see varieties in this market. It will not be dominated by a particular type of tender. And we have seen that evolving over time. You will see market participation increasing in particular tenders, but something which we need to realize is that market participation cannot be the major source of revenue. It can be an added source of revenue. It cannot be a major source of revenue. If you see all tenders, US, Australia, which are the developed markets, we will not see a single tender which is only merchant market based. It's always a part, because what we have seen is specifically in California and Australia that market starts to saturate over time. So you cannot rely on that market. Obviously risk is also there. So yes, these are the trends that are visible today. The good part is that we have started to, at least have 2-3 value streams together in tenders, not just addressing one, which makes things easier. And yeah, I think that has been the overall trend in the market over the last 2-3 years.
Thank you, Debmalya. I think there were very good insights in there. And so building upon the tender discussion, like which design and several designs over the years, I will take the developer perspective now. Over to you, Lakshmi. So we have seen an evolution on ESS tenders, RTC, peak power, and the latest is FDRE. So from a developer perspective, what do you see in FDRE? Like what are the major advantages that it has over the previous iterations, and maybe some shortcomings that you can point out?
Yeah, thank you, Prabhakar. So I think thanks for giving this opportunity. So I mean, to answer your question, I mean, see, look, the way I think if you have to craft a solution for this FDRE, I think you have to strike a balance between their reliance on exchange vis-a-vis how much of battery that you're going to put. So the overall cost or the landed cost of electricity, the price of electricity is going to depend on what arbitrage you take in terms of battery vis-a-vis exchange. So typically what happens is the inclination of large IPPs is going to be towards and taking it towards an exchange. But the inclination will definitely be towards exchange, because that's how you be more price competitive than being dependent on exchange. So to that extent, I think I second what Debmalya said, is that there has to be a mandatory battery requirements. Otherwise, this arbitrage is what people is going to play with, right? So now what happens in this, of course, this is the tender that has to be the future of the country, because this is what discoms are going to like, because they don't want something like you just dispatch it, inform, and they have to finally take it and pay for you, and they have to curtail the thermal power and pay the fixed charges. It's going to be a certain burden on them. So typically, I think this is what discoms will love. But of course, the primary aspect when discoms look at these things is about at what price does it come, right? So under those circumstances, what happens is I think it will put a pressure on the volatility in exchange. So the prices in exchange are going to, swing the other way. And there is, I mean, the demand of the discoms are low, I think, and you have designed a system such way that the reliance is more on, the exchange sale. Then typically what happens is that the prices on the exchange are going to drop. And similarly, when you're going to be on a shortfall basis where discoms, you are not going to fulfill the demand of the discoms, you have to pay a penalty. And of course, the discoms have to then rely on exchange to buy that power at the time the price shoots, right? So typically what will happen is it'll actually disturb the balance in the exchange. That's going to be a tricky aspect, when it comes to these kind of tenders. But I think if you carefully balance the two aspects, taking the risk into consideration, that the long-term exchange risk and other things, I think we can this is going to be a very good tender, and it will actually accelerate the deployment of ESS in India.
Okay, thank you, Lakshmi, for that. Next, building upon that, I would like to invite Mr. Debabrat. So the main point that every stakeholder points to for storage is the price that they say that it's expensive. And and we have seen multiple tender types and multiple tariff that has been discovered. We have seen tariffs of more than 6 rupees, and we have seen tariffs of 3 or 4 rupees in different tender types, like in RTC or and in peak power supply. So what are the key parameters that influences the discovered prices in energy storage tenders? Maybe you can structure your answer based on tender type, like in this tender type, this is the main factor. Over to you.
Thank you, Prabhakar. Thank you for the opportunity to come up and sit along with my co-panelists. Majority of the factors considered have been covered by my co-panelist, but still I will round up what are the key factors that we are looking into it. It all depends upon the application. If you talk of a perspective of a utility like NTPC or Ayana, for us, it is the FDRE or the RTC that is into consideration because we are major developers looking at. So in that conditions, it would be the load shifting or catering the surplus that we'll be focusing on. It can range from 20 to 40% of your total energy, depending upon how good of the optimization and how good of the complementing sites that you have developed for your solar and wind oversizing. So that would be, but when you come to the perspective of a transmission utility, undoubtedly for them, it would be the number of hours of discharge and what would be the quicker response that they look out for. So the basic tenders of the standalone ESS, when you see from the transmission utility perspective, you would be finding that to be on a higher number side because that is, the only component involved in the total deliverables. If I'm to quote, the peak power supply was for ₹9 per unit, and when you put that into energy mix, you have a lower component of solar, which is accounting for around 2 to 2.4 rupees per unit, and you have a wind which is contributing around 3 to 3.5 rupees per unit. So, and the energy storage forms a 10% of the component, if I am to say, for FDRE or a RTC. So taking those lower components into the combination, you find a discovered tariff of 4 to 5 odd rupees per unit in the FDRE or the RTC tenders. So that is the main factor. While you are looking for a utility, again, as I said, it is around 2 to 4 hours of peak hour dispatch or firm dispatch that we expect. And for a RTC or FDRE, then you have a 6 hours or more kind of storage requirement to address the block wise availability constraints in a tender. Yeah.
Thank you. I think you mentioned like discharge hours as well as the price of individual components are like the main contributing factors. For
finally, it is the LCOE that matters to a developer, and on the basis of which we are going for a PPA. So the best it suits to our business requirement, then that is what we go for.
Right. Okay. Thank you, Debabrat, for that insight. So so Lakshmi, I think Ayana is already under commissioning REMCL RTC tender, and so can you share us your experience? Like, has there been any operational, technical, or any kind of challenge that you are facing in commissioning that project? Where and what is the status? Maybe you can shed some light, or any other project that Ayana is doing in the energy storage space.
All right. We haven't reached a commissioning stage because I think we have signed the PPA in the month of June only. So, it's 24 months for, completing the project. So the project will see the, light, I think maybe by June 2025. Okay. So I think, currently we have a 300 megawatt of RTC with REMCL and a similar, contract with Hindalco. It's, the first CNI project with round the clock energy supply. The terms and conditions are slightly stringent over and above what is under the REMCL contract. So typically here, I think, so we have done contracting, sizing and everything internally in-house. And, for the storage, we have tie-ups under the lease model. So I think from a perspective of, designing the solutions, we have completed all that. Now things have to be put on the ground for I think the Hindalco project, we will be ready by end of next year. And maybe 6 months hence, I think, we'll be ready for, the REMCL project as well. So in terms of technical challenges, I think, yes, Mr. Debabrat said, it's about finding the optimal mix of sites as well as, the components that you're putting, unlike a traditional solar or a wind where your capacity is pretty much defined here, it's actually backworking for meeting the obligations under the PPA. And the obligations are slightly stringent when it comes to pure play RTC, and we are talking about RTC with renewables and not with thermal. So, or, so we have a time block commitment of 50% of the contracted capacity throughout the year. And of course, 85% annual availability. So when it comes to this kind of a stringent obligations, and that too being, totally served with renewables, the usage of battery becomes mandatory. I mean, any form of battery. So we have designed something as a mix of both PHP and, stationary storage. So with that, and of course, the challenge has been in terms of how do you mix and balance each site separately. Where do you put your solar? I think solar across India, the profile is not much different. So, you get a flattish or probably a duck curve. But when it comes to wind, I think things turn out to be a little different because, each region has its own profile, varies across different seasons and stuff. So you need to kind of optimize design algorithms which optimize and, overlays the profiles and finds out the right mix at different geographies to be able to meet those. And then obviously then comes the storage, because we are working on based on long-term historic data. And it doesn't mean that it's going to work even if you project do a long-term correction and projections from those things. It doesn't mean that it's going to perform in the same fashion. Probably whatever you have predicted in this 15-minute time block may actually blow the next 15-minute time block, but still your overall generation will remain the same. But here, given that the nature of solution that is being provided is that it's has to match on a time block to time block basis, right? So that way, I think that's where storage comes in and tries to fix those, any kind of movements and other things. Plus also at times when, when all the resources are not working, or probably, most probably it'll be the night time when I think the solar is not available and wind may not be available in any of the time blocks. That's when storage kicks in and tries to bridge the gap. So in this solution, the storage becomes a little more mandatory. The other option, as I said, was, reliance on exchange and other things on oversizing the solutions, but may not typically work out when it comes to time block based availability guarantees, right? So that way, I think we have done the solution, and probably I think the biggest technical challenge that we are trying to kind of solve for the next, I would say the next bit of challenge is going to be the scheduling and forecasting associated with these solutions. I mean, one is of course designing it on a piece of software, then the second is about implementing it on ground. So that's going to be even more challenging than this is all mathematical, but that's going to be real ground challenge. So we are building our backend IT infrastructure, building algorithms to kind of, do permutation combinations of, various availabilities and other things across sites, and try to, fix the dispatch optimally, so that, I would rather say that we are meeting the obligations to the maximum extent possible. And of course, maximize the revenue for the organization. Yeah.
Thank you, Lakshmi. Did you face any regulatory challenge also, like wherever you're setting up your project, maybe from a central government perspective, or from the state where you're setting up your components? Like, is there any regulatory challenge specific to ESS? Because ESS is still under development, the sector, and the regulatory part of is also under development, constant development. So
Correct.
Have you faced any challenge?
Yeah, so there are, state level challenges not to be undermined, is that, there are several state level charges which is applied when it comes to, when it's just, waived off when it comes to a generator vis-a-vis, when you are a consumer, right? And I think on that perspective, I think CRC has clearly clarified that a storage entity to be treated as a generator. But there are certain provisions of the state electricity, which gives the state, its own kind of putting a own or a justification, or rather inference of how it is to be treated. So under those circumstances, I think what will happen is, because the storage necessarily buys power as well and also sells the power back. So under those circumstances, there are certain charges which may be levied. We don't know as of today how the state regulators are going to react when large number of projects comes up like this. But I think, the thin line that is there is that, a lot of these storage projects are ISTS connected. So maybe the interference that we expect from the state regulators on these matters may be minimal. But, obviously, when it comes to a state regulator, I think they are more profound on the geography of the installation rather than whether it is connected on ISTS or a state network. So there are those regulations. I think the deliberations are happening at various levels, and hopefully we will see some kind of clarifications emerging on a national level, clarifying all those charges and other things very clearly.
Okay, thank you, Lakshmi, for sharing all the challenges that you're facing. Over to you, Debmalya. Like we listened to Lakshmi specifying the challenges that he faced in that specific project that Ayana is commissioning. So, according to you, what are like overall challenges the sector is facing right now? Like we have seen some of them summarized in the slides, but like challenges, if you want to highlight some challenges, like these are the main challenges that ESS sector is need to overcome in the next few years to finally grow unparalleled.
Okay, thank you. Difficult. Too many of them. But okay, let me summarize. Some of them come from policy flip-flops. Okay, if I'm building up a portfolio, if I'm building or bidding for a project, and suddenly policies or regulations or incentives or tax schemes change, my model goes for a toss. Okay. Second biggest thing which I am seeing today is till the point we have a buyer who is ready to buy my power, it's much risk-free for me. But wherever we don't have a buyer and we follow the old technique of, okay, let's have a PPA first and then we go and sign a PSA. We have seen projects which has been awarded, but still not, been signed. The PSA has not been signed. They have not found the buyer. We have seen prices being negotiated even after a reverse auction. Okay, and we are not talking this of solar. We have seen that in solar, but it has happened in storage too. So these are things which, of course, I understand it's a new industry, so it will face a bit of this, but going forward, things can stable down. One good thing, if you see, compare the last year we had 14, tenders which were released. Out of those 14, 6 got cancelled. Okay, 6 got cancelled. Some got downsized, delayed, then cancelled. Some went through ERA, then got cancelled. These may not send across the right signals to anyone who is entering the market or who is in the market. Okay, I have been advising a few players, and this is a question which we often get, specifically in players who are not in India but wants to enter India. What happens if the project gets cancelled? Okay, so these are things. Now, one more thing which is happening globally today, if you see the lead time when you give the order and when it is dispatched, this lead time for batteries has actually gone down. Guess which lead time has increased worldwide? Any guess?
Well, maybe some country from Europe.
No. The lead time for transformers has increased multi times, and this is being faced globally. Okay, and that is again, as Debabrat also said, it's also down to the component levels, right? If you don't get one component, also you have to wait for that. So I think those kind of dynamics will remain, but on the price front, we are expecting a reduction. So that is a good point. I think with the number of tenders that we have open today, if we have cross-fingered, if nothing gets crossed, next year by this time, we will have a lot to speak about successes that we will get. Early next year, Fluence and Renew together will be commissioning India's first big-scale project. Okay, and we may have a few more if things goes as per schedule. So I think it's time now that we get into real numbers, real projects where learnings will be faster. Of course, it all looks very good on whiteboards and presentations, but I think it's time that we get down. And saying which, US in Q3 2023 has installed 6.7 gigawatt of projects. So yeah, we have a long way to go.
Rightly said. So Debmalya, like building up, like we talked about challenges. So trying to address those challenges, government has to factor in a lot, like with policies. So according to you, what has been the most impactful policies that the government have issued regarding ESS in past few years, and any kind of recommendations from your side that government, some modification or tweaks that they can do, or maybe entire new policies to address the shortcomings?
Thanks. I think a lot has happened on policies. I actually don't complain much about policies nowadays because a lot has happened. Of course, we are not perfect, no one is, but a lot has happened. If I talk just about 2023, the VGF was very handy. We are still waiting for the blueprint, but whenever that comes out, it will be very helpful, specifically for standalone storage projects. We came out with guidelines for promoting PSP, and we saw what that guideline did, right? Karnataka, Madhya Pradesh, Maharashtra, you have a plethora now, Rajasthan, you have a plethora of pumped hydro specific tenders that has flowed out after that. We saw what the impact on guidelines for RE plus ES has brought about. We are talking about 7 FDRE tenders, which is huge again, right? There was this discussion on waiver of transmission license for a dedicated connection to ESS. Again, a welcome move. Finally, the national framework was released. Now, I just hope that whatever is written there is implemented. Even if the energy part is implemented, that every RE project will have a minimum amount of 5% as per the guideline. Even if that is implemented, the number that we are talking about, 61 gigawatts by 2029 or 30, won't be a big target to achieve. We can achieve that. Okay. The other thing which also was under the the uniform RE tariff implementation scheme, they actually had 2 other brackets for RE plus ESS and RTC kind of projects pool in which they will be adjusted. So we are actually trying to keep oranges being compared with oranges and apples being compared to just apples and nothing else. And of course, we also now one thing that we need is at state level. Of course, 61 gigawatts sounds great at a center level, but we need states to also pull up the socks. Rajasthan was the first state, in fact, which came out and said that, hey, by 2030, I will have 10 gigawatt hours. Of course, it has a lot of thing engulfed in that 10 gigawatt hours, but at least one state came out with that, right? We need more states to come out. We need state-specific studies because every state, and I can tell you this because I've studied a few of these states, and the requirement is completely different when you go from one state to another. So if we have state-specific studies, which is very required, I think optimization of resources will be much better. And I think the ancillaries market, it should just open up now. We have waited a long time. So, yeah. Thanks.
Okay. Thank you, Debmalya. I think those were very valid points. So Lakshmi, same question to you. I think you can factor in some from a developer perspective, like what kind of support can developers look at, or like what kind of recommendations or policies that that the government can release or should issue according to you. What are some recommendations from your side?
So I think to start with, basically till the time I think we don't have our domestic manufacturing ramped up to meet the demands, I think till that time some kind of a concessional duty that would kind of lower the cost. And right now I think we are completely dependent on imports, and the moment you put the though we are seeing cells reaching $50 per kilowatt hour, leading to battery packs like close to 100 and all that, but I think there's an add-on duty to it which makes it a little more expensive when it comes to India. So I think that's the starter. I think a duty, concession duty, and then slowly you stagger it up once you see that there's enough in-house availability of products. So that's one. Second is in terms of, I think, the viability gap funding. At least I think for the moment it has been already issued, so that is actually a welcoming factor. And I think the target is to get to about 6 rupees a unit. I think that's the striking range where I think storage would start, stationary storage would start competing with PHP technologies. So other than that, I think we have trying to see that the storage project gets some input tax credit on account of some GST and other things, which will again, I think on a stationary storage project, I'm saying standalone ESS project, will also see some kind of a benefit and lowering of the cost to the discoms. I think these are some of the things that I could really think of right now, helpful for accelerating. And then I think the government would, I think eventually will do is about mandating storage in any and every tender, so that I think there's a enough amount of demand for the investments to happen in India, and then the manufacturing also comes in at the pace that is required.
Thank you, Lakshmi. I think those were very valid points. So moving on to Debabrat, my next question. So NTPC have recently ventured big into pump hydro, and not only NTPC, like pump hydro has seen a resurgence like nothing else in the past 1 year or so, and BESS has always been there for the stationary energy storage. So what do you think in this coming decade, how this technology comparison will play out? Like which technology will be the dominant type, and will BESS overtake it? And what are your views on this?
Well, I would again just bring in what my co-panelist Debmalya did say. No major technology is going to take over on the other. Everyone will have their own sweet time. At the moment, as you know, we are a developing country and we have an obligation to address the energy trilemma. So the affordability factor comes in first when we see, be it the politics involved, be it any common individual involved. The first thing that would come is the price. So at this point of time, undoubtedly, we are having pump storage, which is coming at a 50% discounted price compared to my BESS. So for the developers right now, it is a technology of choice. But indeed, we are also optimistic that in the coming time, we will be seeing lithium to be something in the range of $100 per unit. That kind of price we can expect. And undoubtedly, with Fluence, in fact, coming up with an 8-hour storage in Australia for Lindell project, if I'm not wrong, they are addressing the technological expectations of the utility stationary project developers. So yeah, and if I'm to see on a long-term basis, there are alternate chemistry coming up, like in the redox there is in India zinc gel that is being developed at Gundama. Sodium ion is coming, which are also addressing your shelf life constraint of 10 to 12 years of lithium to 20 years shelf life. And they are also delivering continuous discharge ability of 8 to 10 hours. So yes, in fact, if we see the scale economics going, in favor of the battery storage, then to the later part of the decade, we can expect the battery storage also to be playing a major role.
Yeah, thank you. And Lakshmi, I think maybe you can answer this one. Like we just talked about technologies, and one of the technologies that is very hot in the market right now is green hydrogen, and it seems to have application everywhere. What do you think its viability for storage? Like how it can impact the market?
So I think hydrogen being used as a storage for, particularly for electrical output use, to me looks very limited as of now, given the, the conversion efficiency. So I think the moment we talk about production of green hydrogen itself, in terms of the value of output, in terms of kilowatt hour itself, the efficiency is close to about 58%, right? So now and then, even if one has to assume that you're using a direct combustion engine for hydrogen, which is currently in the very nascent stage, you have to actually blend it with, currently you have to blend it with some kind of an LPG or anything, or a natural gas to be able to use the existing turbine to convert it to an electrical output. But if I assume that technology comes in, people are working on it, GE is working on it, so there are people coming up with that kind of a technology. But even with that, your output tends to get to an efficiency of 40%. So if I have to just compare that efficiency in terms of any other storage technology, it's actually half of that. So typically you lose a lot of value in terms of just by these conversion efficiency of the electricity itself. But I think as an alternate to that, I think there are a lot of startups coming up with ideas in terms of compressed carbon dioxide and other kind of technologies, which actually are more prudent and probably better in terms of efficiency compared to this green hydrogen. I think green hydrogen will serve more of a purpose in terms of converting it to ammonia, or being used in any kind of steel making process, or that where I think the value addition is much better than production of electricity. So that's the current what I could observe from the numbers that's there out there in the market current right now with respect to hydrogen. But I think in future, maybe I think even if the efficiencies have to improve, I mean, what theoretical limits it would go up something like 70% or that. But even at those points, I don't really think that using this as an output to generate electricity and store from renewables and convert to electricity, typically that is going to be a little challenging. Plus, I think you will, when you are talking about storing electricity from renewables and converting to green hydrogen, I think the natural choice is you go to PEM. So which is again expensive in terms of production cost of green hydrogen, because it involves a lot of rare earth materials. So from that perspective, I think it's going to be not the cost effective solution today, but one, if you think of a long duration storage, like probably you use just solar to store, and then try to use it in months when the solar is not available, or those long duration 12-14 hour storage, it may work out. But I think from an economic standpoint of view, still I don't see a value addition of this green hydrogen being used for as a substitute to ESS.
Agreed. I think very interesting points regarding green hydrogen. Debmalya, looking ahead, we have like ESS tendering market is hard to predict even for 1 year. Like what can happen next year? Like last year, we did not know FDRE would come in and just all the new tenders and all it's the hottest thing in the ESS tender. How do you see the tendering design evolving over the years? If you have some insights or on this, maybe you can share.
Thanks. I think, as I told you, that one thing that will come up in 2024 will be, we will have another gentleman coming into tenders called CSP, RD plus CSP for RTC. And as we talk, a tender is being developed on those lines. Okay. And so I think variations will come. Obviously, RTC and FDRE will remain mainstream, but we will have variations. Once this blueprint comes out, you will have more standalone battery storage, at least 3 gigawatt hours as per the initial declaration. So that will anyways come up, right? So I think these will remain mainstream, and you will have a few other kind of innovative tenders coming up. As I speak, we have the project that NTPC has been doing on mechanical ESS in the Talcher sub power plant. And also they had this, agreement with Energy Vault, which is mechanical ESS, right? Which was again in 2022. So see, that's what I'm saying, that there will be others too, but the mainstream for now, I think, will remain this, because this is the basic requirement. We do not find requirement of beyond 4 hours in this decade, at least. The next decade we will, but in this decade, I don't think that the requirement is beyond 4 hours, at least for India. So I think this will remain with some innovations here and there.
Okay, thank you, Debmalya. I think you have seen market around the globe. What do you think, like in terms of policy or technology adoption, like any potential learnings that India can learn from other countries to develop their own energy storage markets? Any insights on this?
Thanks. I think something that China did long back and US also did was mandatory participation of storage in particular projects. Yeah, no one is saying that you start with 50%. Okay, we can start with a nominal 5%, that every tender will have nominal participation. And then as the market matures, you can take it up. One thing that we did beautifully was that we also kept in our tenders interchangeability. Okay, you can start with the technology, you can change the technology, you can refurbish it with something else. So that has been going good. But what has worked really well, specifically for the Californian market and Australian market, is mandates, which actually ramped up the market. So much so that almost, if you see today, the initial revenue getters for these markets has been the arbitrary ancillary services, right? And they were almost around 70% of revenues were coming from that market. But if you see what has been happening now is that market has got saturated. So the average duration of storage has slowly started to increase from 1 hour to today at 2 to 3 hours, and going up it will only go for. India looks like has taken a leapfrog there and directly went to energy services. Obviously, because ancillary market was not that developed, so they started off with we started off with energy services. But even there, I find that if you want to ramp up, I think tax credits, as Lakshmi also said rightly, that till you have a good base of locally manufactured batteries which come to your project, okay, we would need those tax credits to take advantage of the fall in number. The cost is already falling. If we can have those, the BCD and GST getting at a level where the prices can further come down, it can be more wonderful for the projects to flow in.
Thank you, Debmalya. So I think we can take up questions now. So there is a question. So the question is, are the current FDRE tenders not eligible or not for VGF?
No.
So maybe Lakshmi or Debmalya can, or anybody, like any like, are they eligible for VGF, and what is the eligibility condition for VGF? I think it is SECI tenders basically which are eligible.
No, so the blueprint is not out, so we can't confirm on that. But what is there, this is only for standalone storage projects, BSS project. This is not for RE plus ESS.
Okay, understood. One question that a person has asked: what are the current rates, taxation rates for and GST for BESS and separately for PSP? Like, what kind of taxation are, like, which technology has more taxation, and what are like different taxes? Like, maybe Lakshmi would know something about this, or Debabrat.
Yeah, I mean, see, in terms of PHP, I think the large quantum is, civil works. So typically GST would be 18%. And then on the machinery and other things, it's very subjective. Any electrical equipment, I think it's also subject to around 18% of GST. But when it comes to BSS, I think, again, I think output GST, they have made it to 12%. And the duties and other structures are close to about 25 plus surcharge plus such, if I'm not wrong. I think around those numbers. So I think, it all depends on what do you import and how do you import, whether you are bringing in the entire container or you're bringing in, piecemeal from outside and then you're integrating it here. So the taxation structure differs basis how you are contracting and stuff. So, it's not a single answer today, but yeah, these will be the broad range.
Okay.
Exactly.
Understood.
In terms of a developer, if you ask for the PSP has been majorly a service agreement or contractually driven system as of now. There are 2 or 3 major developers. Other than that, we do not have many players in the market also. So when you go for a service agreement, it is a generally GST of 18% that is being considered. But for when you come for battery storage, you will be having multiple components, and as Lakshmi rightly said, it depends on how much of the imports that you do and what are the countries that are importing from. So that is going to take a consideration. We can expect something on a higher side for BESS at the moment, because majority of that would be import duty and it won't come cheap.
Right. Because of the imports, the BESS will have more tariff or more taxation rates. So there's one question, I think, Debmalya, you can take this, that India is in nascent stage in energy storage space. What are the countries overall the world which can be considered leaderboards in energy storage in terms of like these are the where I think energy storage would not have reached maturity like at a country level anywhere, but maybe region wise, like you mentioned, California.
If you take US, it's ERCOT and CAISO, California and the Pacific grids, more California. But
Right.
ERCOT has been taking lead this season. It has actually taken over California market. Second market obviously is Australia.
Okay.
And you will find a very different market when you go to Germany, where you will find residential storage leading the game. It also depends, similar to Japan. It all depends upon regulation. But yes, leaderboard, I think it's, of course, China, US, and Australia.
Understood. I think we can, with that, we can conclude the
Prabhakar,
webinar. Yeah.
one question was asked,
Yeah.
I guess, in terms of ESO obligation, energy storage obligations were announced in July 22, but the recent MOP Ministry of Power's October 2023 RPO obligation doesn't specify storage obligations being met through BESS. Any of the panelists have any thoughts or views on this? Why is it excluded?
I think yes, there is a gray area there, but there will be a separate circular which will come up for ESO. Is what I have particularly heard on this. So it was not part of that, but it will be a different circular which will come up on ESO.
Understood.
Okay.
So, Charith,
Sure.
any other question that you see?
I think there are a few.
I think other questions are very specific.
Yeah.
Cannot be answered in a webinar. I think that's all. I would like to thank all of the panelists here today for taking out time and attending this and providing their valuable insights. And for all the attendees, the recording for this webinar will be available on our website. And thank you everyone for joining us, and have a good day. Bye.
Thank you.
Thank you all.
Thank you.
Thank you.
Thank you.